Yes, hello everyone. Let us see the next concept in this discrete mathematical structure, that is the connectives NAND and NOR. NAND and NOR, the definition of this NAND says that it's a compound proposition, that is negation of P and Q. It is also read as not P and Q. It is denoted by this symbol P, this symbol Q. This symbol is called the NAND connective. NAND is a combination of NOT and AND. So P NAND Q can be even written as negation of P and Q. It is equivalent to negation of P or negation Q. So this is a definition I can say of NAND function or NAND connective. And similarly, NOR, it's also a compound proposition, negation of P or Q. It's read as not P or Q, is denoted by the down arrow symbol. So this symbol is called as a NOR connective. NOR is a combination of NOT and OR. So P NOR Q can be even written as negation of P or Q, and it can even be written as negation of P and negation of Q. So here we have a truth table of NAND and NOR. See, whenever it's an opposite, NAND is exactly the opposite of AND. If you do the AND operation between P and Q, you used to get 0, 0, 0, 1. But if you see NAND, it is exactly opposite. 1, 1, 1, 0 in NAND, and opposite of OR is NOR. So 0, 0 used to get 0 in OR, but now you are getting 1. So 0, 1, so there you used to get 1, 1, 0 used to get 1, 1, 1 used to get 1 over here, and here all the three are 0. And this is about the NAND and NOR connective. That is the definition you can say, and the truth table of the NAND and NOR. Coming to the examples of this, you need to remember these substitutions where all NAND comes, it can be written negation of P and Q, and wherever there is a NOR, you should remember that it can be written or it can be replaced with negation of P or Q. So if at all we know uh, these substitutions or substitutions, we can get to know that how to simplify the problems. Okay, and here is the first one: negation of P nor Q, so is equivalent to, we have to prove that. Okay, so first let us take this one, negation of P nor Q. You see, if you see this one, first it is applied, negation is applied for this, and here negation of P or Q nor Q can even be written as, here we have that slide, negation of P or Q nor Q, negation of P nor Q can be written as negation of P, negation of P or Q. So why double negation here? A double negation just because it is as good as writing a P or Q. Okay, so further simplification is, it can be even simplified as negation of P and negation Q, as we have here over here, negation of P and negation Q. So if you simplify this, one, so it is in the form negation of P and Q, negation of P and Q. So you can write this, that is negation of, it is of the form negation of P and Q. Considering this as P and Q, it is in the form this one negation of p and q. So you can easily write this as p, considering this as p and p NAND q, not and it is a NAND. Okay, similarly over here, coming to the, as this, as it is negation, p NAND q can be written as, see you have over here negation of p and q, negation of p and q is written, and next it can be written, it is equivalent to writing it as negation of p or negation q, again considering it as negation of the whole thing as p or q. So you can write it as, this is in the form negation of p, negation of p or negation q, it is in the form of negation of p or q. Okay, so it's negation of p or q, so it can be written as negation p nor negation q. So in this way we can simplify the propositions. And coming to the next one, we have to prove that this is not equivalent to this. Okay, this proposition is not equivalent to this. Let us first take this one, p NAND q, considering this as a q, here it is being solved. First negation of p NAND, considering this as a and q, p negation of p and q, it is in the form, considering this as p and q, now we can write it as negation of p and is written, this is p NAND q is considered as a q here. Okay, so that's why outer there is a negation. Okay, now simplifying this part, negation of p and negation of p q and r. Why this is replaced with this? Because we have negation of p, we have p NAND q can be even written as negation of p and q. So here negation of q and r. So now negation of p and q, negation of p and q can be written as, we have this form, in this form negation of p and q, you can easily write it as negation of p or negation of negation of negation will give you this one. So it is, this is in the form of negation of p or negation q. So double negation will cancel here and you can get this particular equation. Okay, and if you see this one, p NAND q. Okay, so that's why negation of p or symbol comes here, r. Okay, and here next negation of p NAND q can be written as negation of p, negation of p and q, negation of p and q, and r as it is. Okay, and next double negation, negation of p and r. So now it comes to be negation of p or negation r, simplification of this. And if you see double negation, always it will be, it will get cancelled, p and q or negation r. So with this we can conclude that this is not equivalent to, uh, this proposition is not equivalent to this. Okay, we'll see some more example also given. Okay, yes, the most simplest one, we'll have to complete it fast. Okay, we have to express this using a NAND only. So the ultimate result is that we have to express this proposition with NAND. In the result we have to get NAND. Okay, negation of p, how this negation of p can be converted to the NAND negation as it is, we have in the laws of logic p and p is p, so that's why it is replaced with p and p as a, we can even write it in this manner. And negation of p and q. We have seen negation of p and q can be written in this manner. Instead of q we have p, nothing else. So that's why we can write it as p NAND p. So most easiest one I can say here. Okay. So the most important thing to be remembered here is p is replaced with p and p. So in the laws of logic this is, I can show you that one. In the laws of logic, p, yes, idempotent law. Okay, p and p. So next we'll see that, we'll see the next example. Okay, p or q, p or q, we have the form p or q, we can be written in this form, that is negation of negation p or q. Why it is written in this manner? It is written in this manner just because p or q, negation of p or negation q. So if you cancel this we will be getting the p or q itself. So now negation of p or q, inner bracket, if at all we solve it, negation of p, and it will convert it to, by using a De Morgan's law I can say, p and q it becomes. And if you see negation of p and q, negation of p and q, we can write it in this manner, that is considering this as negation p NAND q. So it is similarly it is p and NAND q. So here we have the NAND operation. And why it is written negation of p as p NAND p? Because since we have p, negation of p as p NAND p, it is written like this. Same NAND as it is, negation of q can be written as q NAND q. So in this manner we can simplify that. Okay, and the similar example is over here. uh, we'll see that. And overall, the what is the NAND operation, how to substitute the that one, is totally dependent on this uh, dependent on these negation of p NAND q. Wherever, whenever you get such a form, at that time you have to think about whether we have to substitute negation of p or q, or whether we have to directly uh, substitute the NAND operation itself. And with this I hope you you have followed this. And if you have any queries during the query session, we shall discuss that one. And one more problem, just try it out. We'll see the explanation of that also in the coming class, coming live class. Okay, thank you.